Well, thanks. Well, I want to welcome everybody to this webinar. My name is Tom White. I'm one of the authors of the Siemens STEM curriculum. Basically, right now there exists two courses, and Dick and I are collaborating on a third. Dick and I have been working together a few years now, and we both go back a few years, and we have deep experience in career and technical education, and we've worked with a lot of science teachers, bringing engineering into science. So I'll let Dick introduce himself, and we'll take it from there.
Hello, everybody. My name is Dick Blaze, and as Tom said, we've been working together. I would correct his statement by saying a few decades, not a few years. And we worked in the same school district together that created the initial engineering curriculum that became Project Lead the Way, which the two of us are the founders of Project Lead the Way. We created it and developed the curriculum and the training protocols and all of the systems of replication that allowed Tom and I to visit every state in the country and visit schools in every state, and grew the program from one school where we worked to over 3,500 schools in every state in the country. We've also worked for the Southern Regional Education Board, among other things. We've been a teacher, administrator, worked outside of education for a while. We have technical degrees as well as educational degrees. And we have been able to utilize that experience, particularly now with the work we're doing with Siemens, that we feel really privileged to be working with Siemens, a great company that, as you will hear in this presentation, is making this curriculum available in a very affordable manner. We think this is the best work we've ever done, and we hope after you hear this presentation that you will agree. So let's go, Tom.
All right.
Next slide. Oh, did we miss one slide, the rigor relevant slide?
Aren't we looking at it?
No, we're looking at page 2.
The importance of familiar context?
Oh, yeah. Okay, I see it.
Okay. You had me going there for a second.
I know. Oh, dear. Well, this term rigor and relevance has been used a lot for some time, and we feel that it's a very important term because we want this curriculum to be rigorous, but we also want it to have relevance for students. And one of the things you'll see as you look at the curriculum is that we put all the projects in a context that students can relate to. So if you go to the next slide, Tom, we have, this is a picture of a technical drawing book that I have here, and on the right side of that is just a page from inside that textbook, and they're these books are important from the standpoint that you should have 3 or so or 4 of these in your class, because you may need to look something up in terms of a drafting standard or some sort of technical piece of information, but it's not really a source for teaching project-based learning. So the items you see on the right are abstract parts that oftentimes becomes a source for somebody to use a CAD system to make a pretty picture that may have a name like a gusset plate or a packing gland or some name that means nothing to students. And we've tried very hard to make the projects within this curriculum uh, contextual and also familiar to students. So I'm going to let Tom take that forward so you can see what we really mean by that.
So what you're looking at is a group of students from a school district called Fountain Lake in Arkansas. And they're following this curriculum, and the way the curriculum is set up, every project, brings in important information on a just-in-time basis. So students never learn ahead. They're always, when they need to know something, it's there in front of them, but it's not overwhelming. And you'll notice that they're using notebooks. We believe firmly in keeping like an engineering journal of what they're doing, but they're also using, large note paper, sticking it to the wall. And, later on, they'll take pictures of their ideas. Other classrooms we've been in use whiteboards and things, but they all use this basic team concept where students get a chance to assume roles and to, really, work through problems from beginning to end, following a design process. So if you're looking at, how this relates to the next generation science standards, there's a huge section in there on engineering design, and this fits right with that, in addition to exploring, many concepts in science. So we firmly believe that this curriculum is appropriate for all students. They come in, everybody begins someplace, and then we have students help each other. Now, this was a classroom that I was in. It was probably the least number of square feet I've ever been in a classroom where they're trying to do design. And the teacher was very creative in how she did things. She had these whiteboards up all over the room, and student groups would then jot down on the boards, and when they get around to solving things, each team sat in a little cluster. So it was really kind of good. And students learned that, their friends probably weren't their best teammates because they don't necessarily, are the most dependable teammates. So they learned an awful lot about how to work with people through this process. So there's no fee for the curriculum or the software to the schools. They have to provide some equipment. And earlier this summer, we did some training for some teachers, and there was no fee for that. So, I'll have Dick tell you a little bit about that. We're very proud of the work we did this summer. The first course makes extensive use of 3D printing. We think it's a way to take it from the drawing of the pretty pictures that Dick was mentioning to actually having different people creating parts that need to fit together. So you have to have conversations about what are the capabilities of the machines, and not only what are the capabilities, but how do we design so my part fits with yours. And it's a great learning experience and takes design out of the realm of theoretical into the actual. And the whole curriculum is project problem based. So students have to figure out how they want to approach things. All the solutions are different. So each project leads into the next one. So there's really a progression of learning, but they have to figure out how things go together. So, and this is an example from the second course, and the challenge was to create a interlocking top and bottom. And so they programmed it and they cut it on a CNC mill, and the two pieces have to fit together and actually mate and be flush and look really good when they're done. So if you'll notice, people spend an awful lot of time with pencils and calipers, and they learn hand sketching and a lot of things first so they can develop ideas quickly and also communicate ideas quickly. And so when we talk about the skills that people want to see from the students that graduate from these programs, and you'll find that these are the skills that are most asked about, leadership and teamwork, problem solving skills, and if you'll notice, the technical skills rank in number 10. They're really important. They'll get you in the door, but then if you've got these other skills, then you're much more employable when you're at the end. So what we try and do is to build all these into the projects. And one of the things that the colleges that we've talked to say that is the students don't have anywhere near enough of these skills. They also mention other things like the ability to use Excel and some other things that are very common in the workplace, but not very common coming out of schools. So we took all these and we built them into the projects. We figure if you are doing these things in every project, you're going to get much better at them. First time through, they're not as good as you want them. And then after you get a lot of practice, it comes in handy. And there's extensive use of Siemens technology through all these. And the technology is, industry standard. It's things that people will see in every state and municipality in the country. Siemens is they're wonderful folks to work with, but it's a very large corporation. In the neighborhood of 350 to 400,000 employees globally. And those folks support industries, everything from sewage treatment to power generation to, all kinds of things. So getting that experience is a great leg up. And part of every project is a presentation element. Now, every presentation is going to be a little different. And the way this teacher went about it was to set up a gymnasium and then invited the folks in the community to stop by and talk to the students about the projects that they worked on. And the ability to communicate what you're doing is very critical to all kinds of jobs for the future. So we force students into following a design process. There's no one cut and dried design process, but there is a way to go about things. And, we, force students into practicing it, and they get very good at it. And so what you're looking at is a project called reverse engineering that, the students do. They take a product and they create sketches and measure and, do the sketches, then they turn it into 3D models with a CAD system, and then they can print their solutions out. So the clothespin on the bottom is really a 3D printed clothespin, including the 3D printed spring, which gave them the most trouble, I think. And so this design process that they're used, they have to go through, and you'll notice that the first thing they do is research. We think they need to know the background behind why they're doing things. And, we break this down. And so they're all familiar with this because each one of these things is split into many subsections so they can follow it through from beginning to end. So right now there's two curricula available. The first one is the Siemens Engineering Design, where they basically learn CAD systems and pieces like that. And then the second course, we call it Manufacturing and Automation. And that's a course that basically follows the first course and then applies it. And we begin to talk about how you design for manufacturing and how you begin to create automation. And the third course we're working on, we've got a tentative title, right now, and that's going to be mechatronics and the Internet of Things. So basically, it picks up where course 2 ends off and takes it to that next level where we can begin to control automation and robotics with smart devices. And so I want to take a quick look at the various projects just to give you an introduction to it. So the very first thing we teach is the introduction to engineering design. So they have a project that basically walks them through not only how the engineering design process works, but also how the documentation works. We think that once everybody has a handle on that, then we can apply that slowly as we go forward. Once they got the introduction to the design process down, then we can go into sketching and documentation. So how do we actually do some sketching? So in our course over the summer, we had several people that had never sketched with a pencil before. So we had to start there, and we said, okay, here's how you create different kinds of sketches and how they work for you. Then the third project, we take them in and we say, all right, so right now you're going to create a nameplate holder. And we gave them some basic parameters, like you have to hold 2 pencils and have your name engraved on it. Well, people have done all kinds of things with it, including a smartphone charging station and all kinds of other things built into it. So these are just beginning places, and students can take it as far as they really want. Once they get that done and they learn how to 3D print, then we can take them and we give them a choice. So there's 3 basic projects that we've lined up, which basically further develops their 3-dimensional skills and documentation skills. One is a sports drink container. And I've seen all kinds of very novel, takes on that. A kitchen tool design, which, whether you have somebody is suffering from arthritis, or you've come up with a great tool for doing some kind of a kitchen process, it allows students to learn about modeling and documentation without taking it out of the realm of something they're familiar with. And the third choice is a chess set, which allows them to do some basic research on chess sets and how the game is played. And at this point, they begin to interview people because, part of this whole process is learning how to deal with clients. So, and when they work with the chess set, they interview people on what would they like to see as a part of their chess set. Then we take them over and we begin to do some rendering and working drawing work. And we do this with something called a shower caddy. So how do you put all the devices that you need for your shower into one common, piece that you can carry. And part of this is they learn how to develop photorealistic renderings. So then, they can basically build brochures and all kinds of other things with the pieces that they've come up with. Then we go into table-driven parts. So all these different, things like pan sets or measuring cups or measuring spoons, they're all very similar in shape. They're just different size. So if you think about the Coca-Cola and all their different size Coca-Cola bottles, they all have a very similar look to them. So, and that's what we're trying to get students to know. And then the last project in Q1 was a packaging design where they have to build some kind of a package for a sports product. So the picture here is of a tennis ball box. They wanted a container to hold a tennis ball so they could be stacked. So Q2, we begin by entering into the assembly and modeling type of thing. And so there's a 3D puzzle that students need to go off and interview people. They pick a client. So we've had people pick nursery school or kindergarten teachers all the way up through I think somebody over the summer I saw had interviewed the folks at some of the office supply places. One of them has a quick buy buzzer, so everybody else wanted something different. So in the process of interviewing, they got a chance to build something that actually made a lot of sense. Then we went through basically building molds. So they had to do some research on what constitutes a mold and how you make things line up. The idea is we pour it with meltable chocolate, or you could also do it with soap or anything else that you can, melt at a low temperature and pour into a mold. There's a optional project in there for a coach's cart. In schools, coaches manage to carry all kinds of things out to the sports fields. So this allows them some place to keep it all organized. And the last project is a reverse engineering project where they take a known product and then they can go ahead and pull it all apart, document each of the pieces, put it together in assembly, and then build a kind of a display of all the various pieces that are found in it. And they're always amazed at the number of pieces in an assembly, and also about how these various parts all fit together. It teaches them a lot about, design and engineering and that type of thing. And, it does it in a way that, they're only researching their own particular problem. Quarter three, we deal with simple machines to begin with. So there's a bathroom door latch and a nutcracker, so they get used to using those. There's a what we call a ball launcher. So basically the challenge is to hit a small box on the floor with a lofted item. So that takes them into Excel to do parabolic mathematical formulas and things to figure out where things are going to end up. We get into some mechanical systems. We teach them how to use the gear designer so they can very quickly create the gears that they need. So this project, the first one is a differential gear design. It's how automobiles manage to go around corners without tearing the wheels off the car. So it's a very common thing, and it allows them to start branching out into how does this work and how are gears made and what are the standards for those. And then we get to the merry-go-round. Again, it's interviewing clients, so their clients in this case might be 5-year-olds, and they have to figure out what a 5-year-old wants to see in a merry-go-round. Quarter four, we get into first project is designing a pedestrian bridge, but it's really all about, what are the forces that we put on things and how, can we actually predict how they're going to work. There's a hybrid toy connector. So what that does is allow you to take something like a Lego brick and combine that with a Lincoln log. And so they get a chance to design some things that, go between. Then there's a playground design where each group in the classroom designs a different element for the playground. So they have to, again, find out what are some of the things that students want to see in playgrounds, and then, how do we make all our designs work together with the theme? And then the last thing we have them do is to select one of the engineering systems. There's centrifugal pumps, there's automatic training wheels. I think that one might be my favorite. It's like, how do you design a set of training wheels that only give the guidance that you need and will get up out of the way when they're not needed? There's a mechanical bank, there's a glider, and a child's toy. So that leads to all kinds of things. Course two, we begin with an Archimedes screw. And so Archimedes screws are used a lot in manufacturing where we're moving dry goods from place to place. There's a X section gives them a choice of two of the next four. So there's a windmill hub. So how do you not only grasp onto these windmill blades that stand out, but how do we vary the pitch on those so we can keep the windmill turning at a specific speed? There's a reverse engineering project, and if you'll notice, the bolt cutters on the top and the bolt cutters on the bottom are really the same thing, except one has been 3D printed. So they have to go through and take a look at how these things are put together and, you know, recreate it. There's a piece for designing a kite string spool. And there's also a bathroom caddy for a blow dryer. So how do we, you know, organize things? And again, so students have some choice. Not every student is interested in the same types of things. So we tried to vary this so it appeal to all students. Quarter two, we get into some CNC work. So the very first thing is engraving. If you think about all the engraved nameplates every place that you go, you know, somebody has to write a program to do all that. So that's the first thing students do. They have to write a program to do it by hand, so they learn what the G&M codes are all about. And then they pick one of the next two projects. One's a soda can opener, one's a game piece design. And then a little bit further on, they pick one of the next two projects. One is a split mold, and the other one is a box design with an interlocking top. So you saw one of the students' projects earlier where they were making the interlocking top pieces. Quarter three begins the automation. So what you see there is conveyors with counters. They're going to pick one of three projects, either a garage door control to automatically lower a door when it's not in use. So they got to get used to sensor inputs. Do we see anybody in the way? Has it been long enough? That type of thing. Sun tracking solar collectors. So if the sun moves, does the solar collector follow? So that could improve your efficiency by about 40%. There's a sort by color using sensors and timers and all kinds of things to say, oh, I see something blue, that's got to go in this pile over here. And then we get to an elevator control project. When you go back in history of Siemens Corporation, the original Mr. Siemens designed the first modern elevator. So it just seemed like a natural to throw in here. And then there's a parking lot gate. So when you pull up and you type in your combination, does it open the gate or does it not? So there's some, you know, intricate programming that goes into that one. Quarter four is all about integrating some of these systems together. So the first one they look at is an automated pneumatic clamping system. And then they get to an automated pneumatic feeding system. So parts are delivered one after another when they're called for. There's a conveyor sorting system, so we can work out which product has to go where. And then finally, there's an automated work cell for a CNC mill. So Dick, you want to talk about the training we did?
Yes. Tom and I delivered 2 training programs this summer for teachers that are going to be teaching the first course this school year. And we did it using the Zoom platform. We did it virtually. And we tried to organize the training in a way that we could model effective virtual delivery of instruction, because we felt that some of those teachers were not going to be doing their classes face-to-face, and that they would need to have a way to be able to do it virtually. So we were able to do it by doing whole class instruction for some parts of it. And then we broke up into what we call cooperative learning teams, we limited the class to 21 teachers, and that gave us 7 cooperative learning teams of 3 teachers each. And those 3 teachers worked together sometimes, and we changed them around a bit when we felt it was necessary to make some changes in that. Um, we offered it on a first come, first served basis, and that filled up pretty quickly. We can also do this, and even though it was offered to any teacher in the country, we can also do this training to a large school or into a single state if that ever presents itself. There was no cost to the school or the teacher for the training. Siemens paid for it all. And again, as I said, we model effective distance learning strategies. And at the end, the teachers were given a 40-hour certificate of continuing education units that they were able to use for their continuing licensure. One of the things that we found very interesting is that about half of the teachers that we were training were science teachers. And as Tom mentioned before, there's a significant engineering design strand in the new next generation science standards. And they told us that because of that, their principal had asked them to teach this course, Siemens Engineering Design. And we had one teacher, a biology teacher, and she said on the first day, if I would have been happier if my principal had told me that I was going to have to teach Japanese than this course, because I am petrified. And if you could see where that person was on the last day, it was phenomenal. The growth and so forth, and the things they were able to do. And so we were pleased with the way CTE teachers and science teachers were able to work together on teams. They collaborated, and it was very successful for all of them. So our goal is to, Siemens has asked us to, the way we did this is we started at 8 in the morning and we ended at 4 in the afternoon for 5 straight days. Now, when school's in session, we can't do that because people have got a job. They have to teach school, so we have a model that we're working out that will allow this to take place in a different mode that will make it possible for teachers to participate in a training component that is not 5 days in a row. So be on the lookout for that. And Tom, you want to add anything to what I've said about that?
Well, I think one of the things the teachers really said was they didn't realize some of the things you could do, like run multiple small subgroups off of one Zoom meeting. So, and they liked the teacher-to-teacher contact. So when they could work through a problem, they picked up an awful lot of skill sets that they're going to use this year. Everybody's a little petrified about, how they're going to make this year work. So at any rate, I think it worked out quite well. So why don't we go on and we'll talk about, this is Studica's information. So I'm assuming since most of you came through Studica that you would already know how to contact them, but this is where any of the components that you need, and really you can feel free to ask them to help you out. And what they'll do is they'll send you a list of the things needed, and then you can go through and figure out what you already have. So you're only ordering the things that you need. And finally, this is how you get a hold of Dick and I. One of the things you'll notice as you go through this is there's lots of questions that you'll have about all kinds of things. And, Dick and I have not saying that we're older than dirt, but we've been around the block a couple times, and Dick has worked with state leaders in just about every state in the nation. I've worked with education leaders not only in this country but in other countries. And one of the things we're working on now is a training program for South America. So Dick and I are going to have to hablar español a little bit.
But we're not
So
traveling.
we're not.
Those
Yeah,
days are
good point.
gone.
So if anybody's got some questions, and I think I saw some questions on the chat board.
Yes.
So, so George wanted to walk through a project, and we can do that. We've actually got some recordings done, and one of the things that if you just send me an email, I will send you a link so you can go in and check out some videos of the courses that we did, which will walk you through project. You'll see some of the other things, and you can see some of the projects that the teachers did because they did a short presentation about those. We had them do what we wanted the students to do. And let's see. The question, John, are you unmuted? Can you actually ask your question in person?
Give me 1 second and I'll try to unmute him for you.
Okay, that sounds good.
Okay, he should be able to talk now.
Hi, John. Can
Hey, how
you?
doing?
Oh, good, good. Can you go ahead and ask your question?
Yeah, there was a platform I use called White Box Learning, which is more of a virtual, but it has the built-in test phase. It goes through the engineering process. The nice thing about the platform is they're able to take the design phase and compete against others virtually. I assume this is sort of not that level of classroom, multi-student design phase that's online. Let's say, I don't know if you're familiar with Onshape or anything like that,
Yeah.
where you could actually relatively see each other's work and compare against each other's work in projects.
Yeah, that's one of the things we did over the summer is we did a lot of that. And the Solid Edge software is it's one of the industry leading softwares, so it can do a tremendous amount of things. And then the sharing of ideas, because design is never done in one place anymore. It's like a worldwide thing. So
Absolutely.
so you've really got the handle on how do you get people interested in digging deeper and doing a better design. It's like, okay, let me see what somebody else has done and getting excited about that.
Exactly. So is that built into some of the curriculum, the ability again to do a collaborative, or let me see what my partner's done, or let me see what another person in my class has done?
Exactly. And so the design teams each have to give a presentation at the end.
Yeah.
But we do a lot of presentations throughout the process so people can
Excellent.
see, well, it's another way that teachers can make sure that students are on task and on target.
Right.
But it's also a good way to have people scratch their heads and, say, oh, I never thought about that.
Right. Okay, thank you.
You're welcome.
Anyone else have a question? Tom, are you going to, if they want to see the video of what the curriculum looks like, they can send you an email and you'll forward the link to that video?
Yeah. Mm-hmm.
And okay, very good.
Well, if there are no more questions, I will Thank you all for coming, and we will, I'll chat with you later when you have questions.
Take care, everybody.